Hello everyone, and welcome to this new online platform, this new online series, I should say, that we are going to start from today, which we are naming it as Ask AuxEn Anything. So, as you all know, we are into this work of taking online courses, and we conduct structural engineering training sessions for structural engineers from various, uh, I would say, from various uh, points in their career. For example, our structural engineers are practicing consultants, working professionals, they are faculty members, and whatnot. So, we have been conducting these sessions for them, online structural engineering courses for them, and we always feel that there are a lot of questions that they ask, which remain unanswered, or we don't often get enough time to answer their queries. So, through these online sessions, which we will conduct weekly, it will be our effort to answer and interact with all the structural engineers, not only who are our participants, but the general structural engineering community as well. So, we are naming this series as Ask AuxEn Anything. Your questions can be related to uh, projects, project work that you're doing, or your questions can be related to any RCC or structural steel problem that you are facing, or they can be related to site and construction issues. So I'll try to answer them. Of course, conducting such a live stream is a has potential risk because we may not be able to answer all the questions because of our limited knowledge. Also, there are things about which we don't know, which we will not be, maybe we will not be able to answer live. And then there are things about which we don't know that we don't know. So maybe uh, during the course of these sessions like these, we come to we come to know the things which we don't know about. So that will give us an opportunity, or that will be an opportunity for us also to study those things to improve ourselves over there. And about the things which we know, of course, we'll try and answer them. So I think it will be a good weekly series that we will be conducting. We'll be conducting it every Saturday weekend, and generally the time will be 7:30 p.m. IST. So it will be a freewheeling conversation. There will be no presentation, nothing. I'll just take questions, and that will be the format. So we have already circulated some Google form where we had taken up questions, which we will take first. Once they are over, then if there are some live questions in the comments, we can take them as well. If someone wants to join the live stream and ask the question, we'll also share the link to join the live stream once we finish the questions that have been put in the Google form. Okay. So let us begin then without wasting time. So you might think that if I don't have a question, what is the advantage or benefit of joining? Suppose you don't have a question, but you are still watching this, or suppose you are watching this session later, you might think that what is the benefit or advantage of watching a session where I don't have any questions. So we think, or I personally think that, as they say, that we learn from others experience, but I guess we also learn from others questions and the difficulties other have. So it might not be your question, but I think the answer may benefit you, because maybe you are also not aware of that thing or that problem. So maybe that, although it was not your question, but the answer may help you as well. Okay. So I think it will be a good uh, series that we are going to start from today. This is the first session. Let's see how it goes. So, what I will do is I'll straight away go to the Google form. I'll share that on the screen, and one by one, we will start taking your questions. Okay. So, let us start then quickly. And what I will do is I'll share that Google form and let us start. So are you able to see this? I don't know what you're able to see. Are you able to see this form on the screen? Yeah. Let's begin with the first question. So, first question, Mr. Yash Chirania, he's joining, or he's from Akola, Maharashtra, and he's asking, uh, when we have to provide eccentric footing, is there any need to provide supporting beams to column inside footing? I have seen few consultants provide while many don't. So this is a oftenly asked question about the need of or purpose of providing beams to footings which are eccentric. So, for example, such cases where you have, and I think you are able to see this. So, for example, you have a this is your plot boundary, and because of the column which was on plot boundary, you had to give this footing eccentric, and then you had a internal column where you had a concentric footing. So now what to do with this eccentric footing? How to take care of this? Many people have different strategies that they adopt. Some people, I don't know, they will do just a minute. They will do something like this, where they will make a column, and I don't know why some people make this type of a shape for this footing. Yeah, have you seen this? Making such shapes. Some people I have seen, they will put more reinforcement, increase the thickness. Some people will provide a footing, and it will have a beam internally, beam that is inbuilt. So this is footing thickness, and they will give a beam like this, and this is their eccentric column footing situation. But in my opinion, all these strategies don't work, because your basic mechanics, the basic principle of mechanics is not solved, or not, uh, I would say, not confirmed over here. Because what is the basic principle? P by A plus M by Z, this should be less than your bearing capacity of soil, and P by A minus M by Z should be greater than 0. So whatever you do with the footing, whether you do a beam or you increase the thickness or you put more reinforcement, if this is the axial load, if it is at an eccentricity, it is going to generate some P into E movement. Now, if there is going to be a P into E movement, chances are very high that this P by A minus M by Z will be 0. To make it less, it will be less than 0, that is, to make this as a positive value, or to say that to make it a condition of no uplift. For no uplift, what you will require, that P by minus M by Z shall be greater than 0. The only way to do is to either put very heavy P over here. Okay, if your column load P increases, naturally your P into E moment is also increasing, so that will not help. How can you increase the P? One way is to put lot of soil retaining load over here, but given the very small plan area of this footing, increasing P beyond a point will not be possible, because it's not a case of retaining wall type of system, remember. So increasing P beyond a point is not possible. Okay, increasing the sulfate may not be very economic. So if you wanted to satisfy this condition, you will end up getting absurd sizes which you may not be able to provide in actual situation. So the only thing that I understand which can be done over here is either to have a system which can take the uplift. So either you can have piles provided below the footing which can take the uplift, or you can have some rock anchoring if it's a case of rock, if you have a rocky hard strata rock underneath to take the uplift, or you join it with a strap beam. But that strap beam should not be like this, uh, just limited to the eccentric footing, not like this will not help. So you need to continue and take this strap beam in a way that it should connect with an adjacent footing, only then this trap beam will work and it will help you to take that eccentric moment. So I don't think any other option is possible if you wanted to, if I were to talk with pure uh, with a case of satisfying the mechanics. So no other strategy is workable. You may increase the thickness or you may increase the reinforcement. I don't think it will work. The only possible strategy which I understand is to either provide a strap beam to connect the eccentric footing with the adjacent footing, or to get a situation or to have some system which can take that uplift. So that can be pile or rock anchoring, etc. Now you may ask that you must have seen a lot of such projects where neither piles are provided nor rock anchoring is there nor strap beam is provided, still the buildings are performing. So how do they work, and how uh, I mean, what is then happening over there? So the only answer I have is it's all with the grace of God. Other than that, I have no answer over there. So to conclude this question, you have to have a strap beam, and that strap beam should be connected to the adjacent footing or any adjacent structural system which will help it to transfer that eccentric moment. Okay. So mhm, where was I? Yeah, so this was the first question. Now I'll just move quickly to the second question. I'm just struggling to, yeah, that is the sheet. So second question is asked by Mr. Mukesh Kumar from Delhi. He is a undergraduate or a postgraduate student. How to get the mode shapes in high-rise structural building? It is the main issues that he faces during the modeling. I don't understand what he means by how to get the mode shape. Mode shape is a, mode shape is a the type or the shape in which your structure will vibrate when excited by any frequency is the inherent property of your structural system. The way in which your structural system is, that is what will govern the mode shapes. So I don't know what he means exactly by how to get the mode shapes. Mode shape is a fundamental property of your structure, and it depends on the structural system, or it depends on the structural properties of your system. So I'm not quite sure what he exactly means by this question. Mr. Sheikh Ahmed Jawad from Bangalore, he is an independent consultant. I'm moving to the next question. He is saying, I would like to ask you regarding the design of the type of staircase which I posted in the group. Okay, so he has mailed me one staircase example. I'll quickly open that and show that to you. And let's see what he has to ask over here. So he had posted his question on the on email, and what I will do is, I guess I can share my screen. Let's do it quickly. So I'll share my screen. And what do we see over here? Yeah. So he's asking about this type of a staircase. Okay, so this is, can you see this staircase? So what they have done is that they are, uh, I hope it's visible. Yeah. So what they are doing over here, that in this staircase, they are climbing from here. They are climbing from here, and then they are taking a turn. So there is a triangular step. I think this triangular step is to accommodate the total floor to floor height. And because they did not have adequate space, they have gone ahead with one triangular step over here. Then there is a bigger triangular step, and then a third triangular step, and the second flight. So he's asking how to detail this kind of a staircase. So to do this, you will need, there can be different strategies for staircase. I often see a lot of questions being asked for the issue of staircase. So staircase, you must understand that staircase has to have, first you should think about the structural system that you will provide for any staircase to support it. That should be your first thought, that how are you going to support a particular staircase. So if I were to tell you, just give me a minute. Yeah, so this is your flight, then this is your triangular step, this is my next triangular, this is the larger triangular, I guess, or I think here also there is one more flight, one more step. So this is one step, two step, three step, four steps. So it's saying how to support this, how to detail this. Number one is supporting system. So supporting system, you must remember the basic principle that you need to have a proper supporting system. Either it may be a system on which your flight is cantilevering, or it can be a system on which your flight is resting on two sides. Generally, we like to have a supporting system where your flight has two supports to rest on. So I think in this case, the supporting system that you can provide can be a beam over here. That beam will have adequate depth so that it is able to catch all these triangular steps, 1, 2, 3, and 4. It should be able to provide support to all of them. Why? Because this beam that I provide over here, it's going to support this flight, and it is also going to support this flight. So it should have that adequate depth. Now in some cases we provide what is called as a this type of a beam over here. You might have seen this type of detailing, this type of a detailed beam, detailing being provided if I have to support two flights on the same beam. But I guess in this case, instead of providing this type of a shape and elevation, we can straight away go for a deeper depth of the beam, which is able to catch all these levels. Okay, so I think this is how it should be designed. So for the design part, you may not be able to do all these things in a software maybe. So maybe you will have to do some manual calculations for that. But always remember the basic principle or the underlying principle for doing any staircase design will be that you should first think about a proper supporting system that you will be providing. Okay. Okay. Then Mr. Sheikh Ahmed Jawad is asking another question. He's saying that he saw this kind of a staircase being provided, which had this type of an element, and he's not sure what it was. So I'm also not very clear what has been done over here. I think it's some sort of a looks like some sort of a cantilever beam maybe that was taken from here. I'm not sure what they have done because I cannot see properly. Or maybe if it's not a cantilever, I mean, that was one possibility that it was a cantilever. The other possibility is that there must have been some issue with the step levels, and they tried to accommodate it by providing this vertical, and then maybe they provided some steps in the in this portion. I'm not sure why this type of a thing was done. To me, it looks like some issue which led to this type of a detailing. However, his question was that whether we should model this as a column or we should model it as a beam. That was his question. Mr. Harshal More is saying that it's a Pardi. Mr. Hiren Desai is saying winders at landing. What is winders? I don't know. I have never heard this term before. Winders. I'm not sure. But I don't understand why this type of a thing was required. They could have managed it even without this. I think there has to be some issue with this level or something like that. So his question is whether it has to be modeled as a column or as a beam, how to idealize the mathematical model of this stair. So suppose you had this issue and you were to model this. I don't know. I mean, in this case, I guess you could have made your flight like this and maybe put a vertical element in your mathematical model. and then this becomes your base slab element. Okay, and then this becomes your flight element, and maybe you can have your either you can do a line element modeling or you can do a shell element modeling, but I guess this can be your vertical element. You can idealize it as a column in your mathematical model. Okay, so that was his question. Moving to the next part of his question that he had asked. So he had asked three questions. uh, where is his other question? Yeah, I think that was the same thing. Okay, so we have answered it. Okay, no. His next question is illustration of idealization of structure for its design and detailing of these flights. So he has sent another image and he's asking how to do the design and detailing of these flights. I don't think that is a problem. This is your beam. So you can have your mathematical model where this becomes your flight. If you are modeling the beam over here, well and good. If not, you provide your supports over here. And that support can be idealized as a pin support or a rigid support depending on how you want to design this mid landing beam. If your staircase is a part of your entire 3D model, then you can model those beams over there, and then you can model the flight over it. Okay, so his question was regarding the mathematical modeling illustration of idealization of this staircase for its analysis. Okay, so I guess we can move ahead. And the next question was asked by, there is some issue, just a minute. Yeah, next question was asked by, next question is by Mr. Karthik from Bangalore. He is asking design of corner footing for both axis movement without strap beam. So as I just answered, if you happen to do a corner footing where you don't want to provide a strap beam, it will be difficult for you to manage its behavior, because mathematically you will not be able to have you will not be able to mathematically control the uplift. So the only way that I understand is either you have some sort of uh, system which takes that uplift. It can be a case of pile or it can be some rock anchoring. So his question is, this is my column, it's a corner footing. How to take the eccentricity about both the axes and how to manage the uplift. So the only answer I have is either you have some pile or rock anchoring or you provide strap beam. Without that, it won't be mathematically possible to control this. Or if it is mathematically possible, also the sizes that you will get will be so absurd that you will not be able to provide them in actual practice. Okay, so yeah, so this was his question. Let's move ahead and I go to next question very quickly. Yeah, so next question is by Mr. Saif. He is from Guwahati. He is a working professional. He is asking how can we give for fabrication drawing for steel, what steps and codes we should follow. Can you please highlight this? So fabrication drawing for steel, I'm sure there must be detailing codes for that as well. Uh, Although I don't remember the numbers, specific code number, but those can only give you guidelines. They cannot give you, I mean, they cannot give you a procedure to make detailing drawings. They can only give you guidelines for it. But I think making structural steel detailing drawings is far more complicated than RCC drawings, because it requires a lot of detailing that has to be provided. You have to have at least three views for any connection that you want to provide. Okay, so for example, if this was a beam column, extended end plate, rigid connection, and if you want to properly have a drawing for it, you'll have to have a detailed, you'll have to provide at least three views which give the proper understanding of this connection. Plus, if you want to have a fabrication drawing, that will of course require a lot of other things, including the cutting lengths, how to cut the member, how to provide curvatures. I mean, what sort of curvatures if required to provide in flange, webs, etc., etc. There are a lot of things that is required if you want to have fabrication drawings generated. So it's quite more challenging than your regular RCC drawing, where you do not need to provide so many details. But for steel, making fabrication drawings is uh, quite a tedious work. So these days there are of course tools like where you will do a 3D modeling, and then those help you to generate the details like Tekla or the steel detailer softwares. So they help you out. But yeah, it is challenging. What are the codes which are used? So I don't know the code numbers. There, there might be some guidelines about the way in which you need to do drafting of structural steel uh, members and connections, but I don't think there will be anything other than that, because code cannot tell you project to project how will you develop these drawings. It can only give you general guidance. Okay, so I don't think there are codes as such. Steps that we should follow, uh, just follow steps which are full of common sense, and try to show as much as details possible. And remember that usually the fabrication drawings is quite a challenging work because it needs great amount of accuracy. Because if the member is cut, the member is cut. If it goes on site and if there is some mismatch with regard to dimension, it is a big problem on site. So you have to have accuracy. So it's a job of a specialist. And if you are not a specialist, if you are a structural designer, I don't think you should be developing fabrication drawings on your own. Take help of some professional who is into this field. Okay, Mr. Alek Katuwal from Kathmandu, Nepal. He is a working professional and he has put a long query. I guess I'll just copy this and maybe I can paste it over here. And I don't know if we can take them over here. Just a minute. Today I'm facing some teething trouble because this is the first time we are taking such a session. So I just have to toggle between different softwares, but we'll manage. So Mr. Alek is asking regarding sequence in E-tabs. He has given a sequence. So his sequence, first we prepare mathematical model in E-tabs, then apply gravity as well as lateral loads. We prepare service model and check modal analysis, drift and displacement. We prepare strength model and design elements. Can you please tell the correct sequence we adopt in design offices? So I think this is a good sequence that you're adopting. You have prepared an ETABS model first. So you have prepared a 3D ETABS model. Then you have applied the loads. Then you have uh, made all the load combinations with whatever was possible. Then if you are following IS 16700 and if your building requires modifiers to be provided as per the code, then you have made a strength model and you have made a service model because the modifiers given are different as per IS 16700 2023. So now you have got two models, strength and service. So now he's asking that we in strength model we will check modal analysis, drift displacement. So sorry, in this service model we'll check modal analysis, drift displacement. So service model is generally for serviceability level checks, like he has correctly mentioned the drifts, the displacements. Modal analysis, you must understand, it's for a general understanding of how the structure is behaving. So you can take that understanding from any of the model, strength or service, but it's a general understanding that how a structural uh, system is going to behave when excited by natural frequency or when excited by a particular frequency. So modal analysis we are doing for that to see the modes, and then if required, if response spectrum method is required, of course we will combine those modes. Of course we'll combine those modal outputs and apply what is called as a response spectrum load in my structural model. So just checking the modes, getting a feel of the mode, you can do it in any service or strength model. But remember that why we are checking modes, just to get a feel, just to get a understanding of the behavior. Okay, and once you want to apply the earthquake forces, depending on the structure and whether it qualifies for response spectrum, then you will go ahead with the response spectrum cases, where then you will need to combine different modes, and you know the process. So can you please tell the correct sequence? Yes, so sequence will be more or less the same that you have mentioned, that you will make a 3D ETABS model, apply loads, and then prepare two different models, one for strength, one for serviceability, and drift displacement. These checks you will use the service model for, and for member design we will be using our strength model. His next question is, do we have to scale the base shear for response spectrum in service model? So when you are checking the drifts as per the codal requirement, the drift, as I understand, can someone help me with this? The drift has to be checked for, just a minute, I'll just cross verify. The drift has to be checked for unscaled base shear or scaled base shear. Just a minute. I'll just confirm. Yeah, so displacements, the code is quite clear. The displacement estimates obtained from dynamic analysis method shall not be scaled. Okay, so you don't need to scale the base shear. Yeah, as many of you have rightly pointed it out, you don't have to scale the base shear when you are checking the drifts. So the response spectrum base shear may not be scaled in the service model if you are sticking just to the drift checks. Okay. Also, shall we have to check for element design in service model? If you have to check for vibrations, if you have to check for displacements, and if the size of those elements, if they are going to govern or if they are going to affect these checks, then of course in a way you are also designing those elements for service model also, isn't it? For example, a beam size that you are providing, maybe it is passing for the ultimate collapse level moments, shears, etc., but it may not be passing for deflection. So in that case, you have to go to service model and change those sizes. So when I use the word design in service model also, maybe the design of members is going to govern. Okay. Then he is asking, do we have to combine earth pressure loads in response spectrum load combination? If so, we have to do it in service or strength. So I guess if required, you may have to combine earth pressure with response spectrum, because those are two different things. Earthquake is different, and earth pressures are different. So you may have a situation where you have a basement wall of a building and your main building is over here, and then there is some retaining load over here. Okay. And that retaining load is always going to stay there because this is a retaining wall or a basement wall. And suppose the earthquake also strikes. So in that situation, we are facing a condition where earthquake is also acting on the structure, retaining wall pressures are also acting on this basement wall. So you might have to combine them both. And my suggestion would be to also make combinations where only one of them is acting. So you make combine them in combination. Also have combinations where only either earth pressure or either lateral loads act. If so, we have to do it in service or strength. Again, in both. When you are checking for service related issues, you will combine them in service model. When you are checking for strength related issues, you will check them in strength model. So you have to make combinations in both. His next question is for foundation design. while exporting from ETFs to save, shall we use service or strength model? This is good. He's asking that, let's say we had two models, strength and service, because we were following the modifiers as given in IS 16700. So now do we have to, now when we have to do footings, do we take the service model or do we take the strength model? That is his question. So I would say you take the service model because we need the service level reactions for the footing sizing. I guess it will be better if we take the service model over there. Although the understanding is not quite clear, but in the code that is, but I think taking service models is more appropriate when you are doing footings. Okay. Mr. Bala is also mentioning take the service model. Very good. Just hold on, I'll be back. Yes. So, okay, so moving ahead with his further questions. Then his next question is model mass. In model mass, UX is 15%. So he is saying that he has a, I don't know what he's saying, model mass. I think he's talking about a particular mode where the mass participation of translation in X is 15%, Y is 20%, rotation is 30%. Is there any rule which direction we have to add stiffness for correct model analysis? I don't know what he means. Looks quite a hypothetical situation where all these three things are getting combined into each other. I don't think there is such a great correlation of translation and rotation seen in one mode itself. So I'm not sure about this question. And as such, there's no rule where to add stiffness. Of course, if your modes were more independent of each other without such correlations, I think it would have been better. But I'm not sure about this question. I'm skipping this. Can we combine two lateral loads in load combination? For example, earth pressure and seismic loads already answered. In model analysis, if we cannot achieve 90% in the frequency less than 33 Hz, how can we perform the missing mass correction? So your code tells you to perform missing mass correction if in case you are not able to achieve 90% mass participation in your modes and the frequencies are less than, I'll just share that. Then there's a procedure given, not a procedure actually, your code just tells you to perform the missing mass participation. Here it is. So if the modes with natural frequencies beyond 33 hertz are to be considered, I hope you're able to see this. If modes with natural frequencies uh, if modes with natural frequencies beyond 33 hertz are to be considered, the modal combination shall be carried out. So they are saying, let's say you had a case where your mass participation was not reaching 90%. Okay, so basically you have to add or you have to do your analysis to include the number of modes in such a way that you are able to have at least 90% mass participation. If suppose you are not able to achieve it, then you have, of course have to add more modes. But if those modes have frequencies beyond 33 hertz, means more than 33 hertz, 50 hertz, 60 hertz, 70 hertz, that means time period less than this, then what you shall do, that you will only include those modes which have a frequency less than 33 hertz, and for the modes which are higher than 33 hertz, you have to use what is called as a missing mass correction procedure. Okay, so that is his question, how to do the missing mass correction. So my answer is I don't know as of now, because I have never faced such a situation where I had the modes which were adding to the 90% mass, let's say, or which were important or which were required in getting the 90% mass participation, having frequencies more than 30 hertz, 33 hertz. Okay, it's in his question. It should not be okay. Yeah. So his question was about the missing mass participation. I am not sure how we do that, so I am unable to answer. Okay, there are some dynamic procedures that you require. So even your code says that you shall follow established principles of structural dynamics for the missing mass correction procedure. So I'm not sure right now. I'm unable to answer. His last question is in shear walls, bottom story, we get huge movements and axial force. How we can minimize that? I mean, I how can you minimize that if you have a wall, if it is attracting those loads, you cannot minimize the axial loads and movements. The only way is you add more walls. Yeah. Otherwise, I don't see any other way in which you can minimize it. Okay, just a minute. Okay, so okay, Alec has he's saying he has mailed the model. So that model had what? What did that model have? Okay, just keep in the write in the message. I'll move to the next question. Mr. Harshal More is joining from Nashik. He's a working professional. He's asking some bigger firms are allowing first mode translational and second mode torsional. At what extent is it correct? See, there's always this confusion many of the people have regarding what to do with the modes. You must understand why we don't like to sort of have torsional modes, because if there is a torsional mode which is a fundamental mode of vibration, that means your structure has a great propensity to vibrate in that manner. Then there is a risk that I'll just share my screen. So why do we don't like to have torsional modes as our fundamental modes? Because if your structure has a propensity to vibrate torsionally during earthquakes, then it can seriously compromise the load carrying, actual load carrying capacity of your member because of that torsional twisting. So you don't want to have torsional modes as far as possible as the fundamental modes of vibration. But having said that, if it is not possible to avoid those, then you just have to check whether your structure falls under the extreme torsional irregularity. If not, then you are allowed to proceed, but then you need to do the response spectrum analysis. But as far as possible, you can try and avoid. But for some shapes, it's almost impossible to avoid a torsional mode in the fundamental vibration modes. So you have to live with it. Just ensure that it's not having a uh, extreme torsional irregularity, and take response spectrum analysis for, I mean, use the response spectrum method for analysis. Okay. His next question is, due to complex planning like basements plus ground shops plus typical this most of, yeah, that's what I'm saying. Most you may not, and because of the shape of the structure also, you may not always get translational modes as the fundamental vibration modes. You live with that. Just check whether your structure is not having extreme torsional irregularity. In foundation design and analysis, which load combinations to use? Should we use the spec X, spec Y, that is RSX, RSY, or should we use the EQX, EQI? This is very important question, because what happens is, and I may not be able to fully explain that thing to you, if you are taking results from ETABS, basically, okay, and here I'm talking more about the response spectrum outputs. There is a thing which is called as the problem of missing sign. I may not be able to fully explain over here, but the thing is that when ETABS combines the response spectrum cases, it will only give you a maxima, minima, but it does not give those outputs with a sign. So, for example, if I had a case where my column was having some uplift in one of the response spectrum cases, I will not get individual signs in the response spectrum outputs. So I am going to miss out on some signs, and that is called as the problem of missing signs. So we have this problem, especially when we take the outputs from ETABS to SAFE, and this can be a problem, especially when you are doing rafts or combined footings where you are missing out on those signs. So, what to do in such cases? Many people use this jugaad where they will, instead of using the response spectrum cases, they will go with the earthquake cases in the load combination for raft design to save from this problem of missing sign in ETABS for response spectrum cases. But is there any codal reference for it? So there is no codal reference for this procedure. It's just a technique that people use. So STAT does not have this problem. ETABS does, about this missing sign that it has. And someone was telling me, although I have not checked it, the newer versions of SAFE 22 has sorted this issue out about the missing sign. Okay, although I'm not sure about it right now. Yes, in footings, what depth top steel need to be given and what percentage, so you can easily find it in the code. After, if I remember correctly, 1000 mm you need to provide top steel if it's not structurally required, that is. So if your footing depth, if your footing thickness, that is, goes beyond 1000 mm, then you need to provide skin reinforcement top and side. Percentage, you can easily check the code. Combined footing, if top steel is not governing, what is the minimum percent? You can refer the code. In combined footing, if top steel is not governing but there's tension on the face, then you can go as per the minimum tension reinforcement percentage. His next question is, if building is 7 stories and there are no irregularities like vertical or horizontal, do we need to do a dynamic analysis? I mean, you have to take that call. You have to take that call. You just check the fundamental mode of vibration. If it is almost like a parabolic behavior, and if you are getting substantial mass participation in the fundamental modes itself, then you can take this call of not doing the response spectrum analysis. Okay, but that is a call that you have to take. uh, yeah, so there is no, I mean, other than that, I don't have anything to add over here. You just check the fundamental frequency, fundamental mode. Just see its behavior and just see what percentage of mass is participating. Okay. So we go to next question. Mr. Deep Mehta is asking, pre-analysis checks to follow after making ETABS model, post-analysis checks to follow after analysis. I think it's a long thing. Better not to discuss over here, because there are lots of different checks you have to follow. Mainly for serviceability issues, you have to do the checks for drifts, displacements, vibrations, etc. Post analysis, that is. For member design, you have to do a lot of other checks. Pre analysis, mainly you check your model, you check if all the connectivities are proper, if all these things are in place, you have to check that. So I think it's a long answer, long discussion, not to take over here. Back calculations or thumb rule checks that should be applied. So generally, I like to check the column loads at least by doing what is called as a tributary area method. So I just check the column loads whether they are properly getting transferred or not, using the tributary area. And I just try to do some sort of basic calculations for moments, just some simple WL square by 8 10 type of calculations. So those are the things I do, that you can also adopt. Okay. Mr. Chirag Mehta is from Ahmedabad. He's a working professional. He's asking, can purlin distance in PEB structure act as lateral supports? Yes, we do take purlins as effective lateral supports, and we can use that uh, principle to take the Ly or Lx, that is the effective length for lateral torsional buckling and the effective length for compression about the minor axis. We can use those principles to take the effective length accordingly. But you just have to remember that if this was the rafter and this was my purlin going over it, so purlin is usually connected to top chord only. So in cases where top chord is under compression, purlin will provide lateral support. But what if in cases of hogging where bottom chord is in compression, so now purlin is only connected to top chord, then what happens? So in such cases, we do provide what is called as a flange bracing. So where we will have this kind of an element attached. Okay, so this element is attached to purlin and it gets connected to the bottom flange also. This is called as a flange brace. So you should ensure this detail. And once you do that, then you can take the effective length factors for the rafter design equal to the purlin to purlin spacing. Okay. Yes. So I hope that answers it. Moving on to the next question. So I'm just trying to go a little bit faster. Uh, Let me see what all questions we have. Mr. Jay Patel is asking, he is from Ahmedabad, he is also a working professional. He is asking, while designing a structure having pile foundation, if pile beam, ground beam which is connected to pile cap, which is subjected to masonry wall load also. What is this question? Is it good to make beam in ETABS or STAT model at support level itself and column node have fixed support and design only pile cabin safe, or better to make fixed support? Handle pile beam in safe model and apply masonry wall loads to it. Kindly suggest which is the more accurate one. Okay, so his question is, suppose he had a situation where he was providing pile cap and that pile cap also had pile beams uh, or beams at planes level which were going to be connected to pile cap. What to do in such cases? Let me show a plan view. So let's say these are my piles. This was my column, and then I had another whatever pile cap. Okay. So his question is that he is going to provide beams like this. Now, should he model these beams in the main model itself? What should he do? That is his question. Yeah. So best approach will be that if you are able for good level of accuracy and proper analysis, you can model these beams in the main ETAP model itself. Okay, and maybe give supports over here, or else you give the column support as fixed, you take it to safe, and then in the safe model you provide spring properties to these piles, provide pile springs, and then model these beams in the safe model itself. That also you can do. So in ETAS model, let's have these columns as fixed, then I take it to my safe, and in safe I model these pile beams. Okay, and then I can put my loads over here itself, that is the wall load, etc., whatever is going to come on these beams, I can put those loads in my safe model. I think that will be a more practical way of doing it. It will be also easy for you to do in such manner. Okay. Okay, good. Let me go to the next question. Wait a minute. Where's the question? Just hold on. I think I lost the questions. This is getting extended. Yeah, so we have answered this. Then Mr. Tosh Agrawal, he's from Raipur. He is a working professional. His question is, I think he had mailed this question to me. So let me take his question. Mr. Tosh is asking, Just a moment. I'll just try and open his question. No, wait. Where is this question? Just give me a minute, please. His question was, when do we need to have separate columns for crane and separate columns for roof? How should we orient? So I think his question was more to do with these types of sheds that he had seen. Let me just take it to the image. Let me take this image to the uh, file over here, and I think I'll share my screen. I have to toggle between many windows, so just a minute. I'm just facing some difficulty. Yeah, his question is regarding these types of sheds. So these are typically called as sheds using the open web systems. I guess first his question was related to this. How can these types of connections be made? So there can be different ways in which you can make these connections. It will depend on what type of column is it. Let me take a case where I have a column made of two channels. So I'm making this column made of two channels, and now I have a system which is of smaller. You can see smaller columns starting from here. So basically these columns below were of a larger size, and these smaller columns, I usually call them as roof legs. They are to support the roof. And why these columns? Because they have to support the crane and whatever. So these columns are larger, the roof leg columns are smaller. So how to make these connections between these roof legs and main column? I guess that is what he is asking. There can be different possibilities. One of the possibility can be that I have put a plate over here, top of this main column. Then I have another plate that I put at the bottom of this roof leg, and then I have these smaller columns, this and whatever. One side was flushing, so maybe it was something like this. And then I create a bolted assembly over here. Okay. And then these two systems are joined. And then I have stiffeners and all those things provided. This can be one of the options. Of course, there can be different possibilities. I don't have a unique answer over here. So I'm just giving you one possibility, but it will depend on the structure. It will depend on the designer. It will also depend on what sort of fabrication they are able to manage on site. Okay. His next question was, when do we provide a smaller size, or how to decide whether a smaller size roof column is required? That again depends on the structure. Usually, because these columns may be supporting some crane, so we require larger sizes to achieve optimization, or for optimization purposes we provide a smaller roof leg column. And after we provide a smaller roof leg, we are able to create a space which can also serve as walkways. Okay. And which can also help you to support that crane. So usually this is the strategy adopted, where we go for roof legs that are smaller and main columns that are larger. But it again depends on the designer and the structure. So I don't have a one shot answer for this. Mr. Shubham Kole, next question. He's joining us from Nashik. He is a postgraduate student. What are the career opportunities? I think I'll skip this question. It is very generic. Let's take technical questions first. Then, if time remains, we'll come back. But his one question was that I would like to address over here. He was asking, let me share screen. So I am skipping his question, which were general discussion type of question in nature. Maybe we can take it some other time. He was saying that this question was regarding the web buckling, steel beam web buckling. Imagine this is the plan of a web, and here I provide stiffeners. One arrangement I provide staggered stiffeners in plan like this, and in another arrangement I provide stiffeners which are in same line. That means like this. So his question was which is better. So in one case I am providing something like this. In second case I had provided staggered stiffeners. Which is better, he was saying. So it will all depend on the spacing and what type of staggering you are maintaining. Okay. So if you are maintaining this type of staggering, then only one stiffener is effective over here. Okay. If you are maintaining this, then two stiffeners are effective. If this stiffener spacing is close by, then in the same 20 TW dimension that is given in the code for calculation of stiffener strength, maybe these two stiffeners both contribute. So it all depends on the spacing and how you are putting these stiffeners. The only advantage of putting staggered stiffeners is that it will give you ease of connections. Otherwise, both systems are equally strong, but obviously it will depend on what spacing you are maintaining for the staggered stiffeners, what spacing you are maintaining for the normal stiffeners. Okay, so it's not about one system being stronger than the other. It all depends on what type of spacing you are maintaining and what is the moment of inertia of the system that you get. Then, uh, who is asking? Mr. Anshuman Adhikari, please throw some light in the assignment of effective length factor ratios for steel design in ETABS. So again, this is a long question. I don't think we can finish this. You must try and not ask conceptual level questions over here because these questions will take a lot of time in answering. He's saying please throw some light on the assignment of effective length factors for steel design in ETABS. I will not take it over here. Although ETABS does a good job in calculating the effective length factors, so it's not a big problem as such. You can rely on what ETABS is doing, but because it's a long conceptual discussion, I'm not going to take this over here. It was Mr. Anshuman Adhikari joining from Guwahati, Assam. He is a working professional and working as an independent consultant. Mr. Anup Kumar from Delhi, he is a postgraduate student. He had sent some models, and his first question was why do we get higher reinforcement percentage in columns at upper floors as compared to columns at lower floors. So why do we get higher reinforcement percentage in upper floors as compared to lower floors? Usually, what is the reason? Anyone? Is ETABS making a mistake? Is it an issue? So it's very basic. You need to understand the design principles for column first. If you understand the RCC design principles for columns, perhaps you will understand the reason. So at the top levels, usually what happens that as compared to lower floors, it will have comparable moments and lesser axial forces. Okay, so in the PM curve, oh, what did I say? Yeah, in the upper floors, it will have comparable moments or maybe slightly higher moments as compared to lower floors, but the axial forces will be lesser in the upper stories. So in the PM curve, you are at this location, lower axial forces. So you will see that at lower axial forces, even the moment carrying capacity of the section is lower. When your axial forces increase, in fact, your till a point, your moment carrying capacity also increases. Okay, so maybe if your column was at this level, maybe if your column was at this level, it although it had a higher axial force, but also its moment carrying capacity increased. That's why it's possible that when you see the percentage, it required lower percentages, and at the upper stories, you required higher percentage. That is the most usual reason why you see that is the most usual reason why you see upper stories getting more reinforcement percentages than the lower stories. Okay. His next doubt is, uh, check the staircase PDF. Best approach to model the staircase. Should I model the staircase flight in ETABS? Uh, okay, his question. I'll just take a screenshot of this and put his question in the screen. Just give me a minute, please. I know we are running short of time, but we'll try and answer all these questions that were asked. Yeah. So he's saying this is his image that he has shared, and he has a seismic zone 4. His question is, if I were to read it out, he's asking, what is the best approach to model this staircase? It is in seismic zone 4. Should I model the staircase flight in ETABS, or should it be sufficient to apply only the load? Additionally, can the lift shaft be constructed without a shear wall? So, for answering your second question first, can this lift core be considered without shear walls or without RC structural walls? Yes, you can do that, provided you are able to sufficiently and adequately manage the earthquake forces. It's quite okay not to have RCC structural walls over here. You can just have your normal small columns and connected by beams. His next question is, what is the best approach to model this staircase, whether to model it in ETABS or not? Some people do like to model the staircases in ETABS because those staircases acts as brace, and in past earthquakes they have shown that they do add a lot of stiffness, which otherwise is not accounted for. So many people like to consider staircases in the model itself. Yeah. But I don't know. Means personally, I don't have a ready answer for this. Whether we should model it in ETABS, not model it. I'm not very certain about it. Maybe if you have a very high seismic zone and this building, in the plan you have the staircase in a position which is going to have, which is going to add a lot of stiffness because of its position. Maybe you would like to model. But if this staircase is in the outer portions of the plan where it's not going to be very significant, where it is not going to add a lot to the stiffness, I think maybe you can skip it. But I don't have a clear yes no answer for this. I mean, you need to take a call and decide. Okay. So, yeah, I mean, I don't have a proper yes no answer for this. It will depend on the position of your staircase in the overall building plan. But yes, problems have been observed, have been seen in past earthquakes where staircases acted as a brace element and they provided a lot of unaccounted stiffness. Mr. Jay Patel is joining from Ahmedabad. He is a working professional. He is asking, what is he asking? While structure with underbeam piles, dead load, live load, earthquake, and if wind is applicable, first we need to find the number of piles based on reaction. Uh, if ETABs used for maximum possible and after finalization number of piles, yes, you can. The procedure that you have mentioned is okay. We generally do that, and that is how we have discussed it in our courses also. Uh, so yes, you can follow this procedure, and you can do this jugaad type of calculation for finding out the spring stiffness. So we have discussed this adequately in our foundation course. I think that procedure is good to follow. Okay, you can do that. Mr. Balaji from Goa is a working professional. He is saying, please tell us about one-way shear and two-way shear and how it helps. What helps? It does not help. How it helps in making isolated trapezoidal footing. I'm not. Okay, he's asking about the one-way shear, two-way shear calculation and how it helps in making. I'm not sure what is the meaning of help. If you are asking about trapezoidal footings, how to calculate them, I think this is not the. I don't have the time right now to explain it. So maybe you can refer to any good book. You can refer the book by PC Varghese or Pillai Menon. They have detailed procedures for finding out the trapezoidal footing and its dimension. Okay. For combined footings, also you will get the procedures, manual procedures for calculation. But beyond a point, doing manual calculations for combined footings may not be possible, especially in cases of differential loads. And if you are not able to, what should I say? If you are not able to match the load CG with the footing CG, you will get problems of differential settlements, which you cannot manually calculate. So it's best to use some software where you will be able to do that. Okay. Yes. So this was Mr. Balaji. Mr. Deepak from Guwahati is He is asking, please share some information on how load transfer of lift core wall. Please share some information on how load transfer of lift RCC wall takes place in building if we don't model it as shear wall, and how to incorporate this in foundation design. So if you are not modeling RCC core walls and you are going to provide columns and normal beams, just a minute. If you are going to provide normal column beams in your core wall, for example, was this case. So Mr. Anukul had decided not to provide a RC core wall and just provide columns and beams. Then the load transfer obviously will take place from beams to columns, and columns to footings. So in that case, most usually we'll provide a raft like thing for these four columns, because the lift base also requires a raft. Okay, so we can have this type of system in section where this is my ground level, whatever, finish level, and from here usually 1.5 meter to 1.65 meter depth is required for the lift pit. And if your soil is suitable enough, I can provide my raft for this lift core wall over here, and then I can have my columns from here. This can be a retaining wall because it will also have to retain the fill over here. So these will be my columns, this will be my wall, concrete wall, this can be my raft, and this is how I can provide my system. And the load transfer, simple, from beam to column, column to raft. This is the usual system we may adopt. Okay. All right. Moving ahead quickly. What are the other questions we have? Just a minute. I'm facing some issue. Just a minute. Yeah. Very nice. Mr. Azhar is asking, uh, please can you explain how to detail reinforcement in staircase drawing? When will top extra bar be provided at floor level in base slab? If you have a case where you have got hogging moment, uh, then you may have to provide top bars in the base slab. Okay. So it all depends on the type of staircase. It will also depend on the bending moment. So according to bending moment, you will have to do that. His next question is, how much length of the bar to provide when crossing bars? In SP34 it shows LD or LD by 3. Could not understand how to measure L. Okay, I will have to check the SP. I guess someone had put that, Mr. Sheikh Ahmed had put that diagram, the SP34 diagram. Let me see if I can get it quickly. Otherwise, we will forward this question to the next session. Oh yeah, we get it over here. Very nice. So I'll just share this image. It's taking some time to switch between different softwares and to share one screen to stop sharing other screen. It's taking slight time, but we'll manage. Yes, so he's asking what about this LD and when to provide this top bar. So my answer was you provide this top bar over here if there is a hogging moment in the zone over here. How will you know whether it's a hogging moment or not? That will of course depend on the bending moment diagram and the type in which you are supporting your staircase. Then he was asking LD by 3. I don't have the image right now. Perhaps if someone has the image, he or she can put it over here. Uh, Otherwise, we'll take this question later because I don't have the image ready with me. Always try and share the images also so that we can take the questions quickly at a quicker pace. So I'm skipping the second part of his question, and then I go to Mr. Jay Patel, who is also a working professional from Ahmedabad. Which consideration to be taken in design of fabrication hoist lift? Which loads to be taken? Any additional consideration required for raft design of fabrication hoist lift? I'm not sure what a fabrication hoist lift means. You need to provide some sketches, etc. Mr. Pawan Patil from Nashik, he's a working professional. He's asking about column rebar percentage. Why column rebar percentage suddenly increases at intermediate floor level? So it increases mainly at upper floor levels. I already told you. I just now explained why it happens. About footing bearing pressure query check. And that's not the only reason. There can be several different reasons. So it's not a one line answer that I can give over here. Okay. So it may depend on a lot of factors, one of them being the PMM interaction, but there can be other factors also. So it's not possible to give you a one line answer for this. Also, he wants to ask, also, I want to know that whether we should give steel accordingly as per Yeah, that depends. His question is whether we should give different reinforcement percentage at different floor levels or should we continue the same reinforcement percentage throughout. It depends on the way in which you choose to provide detailing. In multi-story buildings, you can change the reinforcement in steps. Steps means for some floors you provide some reinforcement percentage, then you vary. It will depend. So I cannot have a one single line answer over here. It depends. Will it be correct because detailing may be 20 bar lapping on 12 mm? Yeah, you can lap higher bar with lower bar. There is no problem with that. There are rules about it given in SP34 which you can check. Okay. About then his next question is about footing pressure check. Should we consider below load combination zero point 0.9 det plus zero point 0.8 EQ? I'm not sure from where you are getting this load combination. I have never seen this combination for bearing pressure check. So the combination when you combine dead load and earthquake is dead plus EQ or dead plus wind. So I'm not sure from where you are getting this combination. About dynamic analysis, I guess I have already answered whether to go for dynamic analysis or not. Should we check long-term deflections for beam above 7 meters? If yes, how? If you want to check long-term deflection in a technically correct manner, you have to do as per the creep analysis. If you don't want to do the creep analysis, then a shortcut sort of a thumb rule can be that whatever deflections, here I'm assuming you are not providing modifiers, so whatever deflections you get from your elastic analysis, let's call it as the short term deflection. So for example, from your elastic analysis, which did not have any modifiers, elastic analysis without modifiers, you get some short term deflection value. Okay, or you get some deflection value delta, let's call it as the short term deflection. So a general rule, not a rule, I would say a general uh, general practice that you can understand that the long term deflection will be, of course it depends, but it will be almost 1.5 to 2 times this delta that you got. So for example, you did an ETABS analysis where, mind you, you had not provided any modifiers. You got some deflection of 10 mm. This was the short term deflection for dead load plus live load. So your final deflection can be in tune of 15 to 20 mm. So now this is the long term deflection. Sorry, the long term deflection can be in the range of 1.5 to 2 times the short term elastic deflection. So now this deflection value you cross check with the permissible deflection values given in the code. Okay, so I guess that is the way in which you can do this work. Otherwise, if you have to be extremely accurate, the proper way to do is to use the do the creep analysis. If there is a floating column from fixed girder beam, then do we need to give moment release? It's a contentious issue whether you can give moment release and whether a proper detailing is possible. I'm not sure about it. It is best not to give any moment release over there because you may not be able to do the appropriate detailing. Some people provide some crossbars and all those things. I'm not sure how it works. So I'm not answering this right now. Although, yes, this is a problem which many people face, and what people say is that you provide for planted columns resting on beams or floating columns resting on beams. Some people use this concept that they will assume that this, let's say, this is my beam. In section, I'm showing you this is my column. So many people say that uh, they will assume a pin support over here because they wanted to release the movements in the beam. And for detailing, they you must have seen this type of detail. They will do something like this. Now I'm not personally sure how much it works, what happens, so I am unable to comment. But this is the practice I have seen many people adopting for the reinforcement. Although I'm not very sure, so I cannot comment on it right now. Okay. Okay, good. Moving ahead very quickly. Dr. Harish, no, sorry, Mr. Vinayak is joining from Bangalore. He is a working professional. How to calculate the pipe load, vertical and horizontal load in attached image. So I had shared one image. He is saying how to calculate the. Just a minute, I'll just show that image. He's asking how to calculate the vertical and horizontal load. Uh, where is this question? Just a minute. Yeah, so he had shared this image with me. Now, calculation of vertical and horizontal, although I'm not sure about this answer, but I guess it will depend on the pipe pressures. I will first share the image, then you will get it. So, where is the image? Yeah. So, this was his image. He is asking how to calculate the pressure, vertical pressure or vertical force rather. If suppose I wanted to design this element, how to calculate this pressure and this. So I'm not sure because it will depend on the what on the contents of this pipe, what is contained in the pipe, what is the operating pressure over there, what it will attract, have some thrust, it will have some downward thrust, some upward pressures, etc., etc. Plus there will be the self-weight components of this pipe acting on this support. So I'm not very sure about it. You need to have some data for the liquids or for the contents inside the pipe, how much thrust they are going to offer, and all those sorts of things. So, I mean, I don't know much about this right now. Okay. Okay, very good. Mr. Shubham Kole is adding pipe loads are given by piping engineer. They do the stress analysis. Yeah, so I am unable to answer it. It's beyond my scope. I guess. What other questions we have? Let me just share my screen. Just a minute. Yeah, very good. So, Mr. Shivanand from Bidar is a working professional. AI for structural engineers. I'll skip this right now. Uh, this is maybe time for some general discussion sometime later. Mr. Rohit R from Shivamoga. He's an independent consultant. In ETABS, after the analysis, we get results, and after that, if we change the column size, the result changes. That is obvious because oh, he's saying if we change the column size from 230 450 to same 230 450, these size results change. No, I don't think it should change if the column size is remaining same. But if your sizes are changing, the results are ought to change because the stiffness is changing. So that is quite obvious that results will change. Although if you are also changing the orientation, then also it will lead to changes in stiffness and it will lead to changes in analysis results. But if you are keeping if all things are kept same and you are doing the analysis and you are running the analysis again, I don't see a reason why it's happening. I'm not sure. Mr. Palash Jain is joining from Gwalior. He's a working professional. He's asking how to check cracking of structural walls in 3D ETABS model for decoding for deciding stiffness modifiers as per ACI 318. Which shell stress component to be compared? No, I don't know. I don't have the answer. I'm sorry. At present, I use the same modifiers which are given in the code. So basically, for RCC walls, because you don't have the moment modifiers for the in-plane movement, we usually take the F22 modifiers for the sort of the moment modifier for the in-plane movements. Okay, F22 modifier. Mr. Ketan Mahajan from Jalgaon is a working professional. He is asking how to design a slab for cinema hall lecture room where the slab is in incremental pattern. So he's saying that his slab is in step like format. There are steps how to design. Again, it cannot be a one line answer. It will obviously depend on a lot of other issues. So sometimes you can provide an actual folded plate. Okay. So suppose this is my one way can be that you have an actual folded plate provided. Okay. This can be folded plate, actual folded plate. Other option can be that you have a flat roof and the steps are made in lightweight, whatever, some lightweight building material. That can be another option. Other options can include making truss over here and then separately doing the steps. So there can be different options. I don't have a one line answer for this. It is situation specific and it will depend on the particular project. Okay. Okay. Very good. Mr. Saurabh Tripathi, no, Mr. Chinmay Sarkar from Alipur Duar. He is a working professional and he is asking in a building if I provide column capital to accommodate a beam instead of increasing the column size, is it a good option? Yeah, I mean, if architecturally it is okay and structurally you are able to design it, I don't see any problem why you cannot do that. So if you are providing column capital and aesthetically, architecturally, it's okay. I don't see you not being able to do it. His next question is, in a G plus 13 building, can I make up to 4 floor flat slab and rest beam column system? What will be the R value? So usually you may take the higher R value, sorry, you may take the lower R value to ensure the higher earthquake forces. I think there is a line mentioned in 1893 that when two systems which are having different R's are combined, when two structural systems having different R's are combined in one system, then you take the lower R. I guess there is some line like that, so you could do the same. Is it good for that building? Yeah, I mean, why not? If it's required to have flat slabs till a particular level, maybe due to some commercial purposes, maybe you have to do that. I don't see why you cannot do it. Okay. Uh, his next question is it better to provide camber in beam instead of increasing the depth? Managing camber in concrete may be sometimes difficult. So, if you are able to manage that camber, and if the beam, the reduced beam depth, that means if you're not providing the camber, you want to reduce the beam depth. If that beam depth is satisfying all other checks, maybe you could do that. But providing camber in RCC is difficult. Not many people are able to provide it in a proper manner. So it's a call that you have to take depending on the capability of the contracting agency. For structure design, should we use, his next question is, for structure design, should we use only dynamic load combinations or both static and dynamic? No, if your structure says that only response spectrum is applicable, then why would you use the equivalent static load combinations? Only use the dynamic load combinations. I mean, only use the combinations which have the response spectrum load cases in it. For separation gap, should we calculate the deflection for unscaled or scaled? For unscaled, it's quite clearly given. We had seen this during the initial phase of the session also, that it is to be calculated for the unscaled. Okay. Yeah. Mr. Neeraj Patel, no. Mr. Siva from Srinagar, he's a working professional. He is saying several warnings are seen in StatPro analysis of structures. How can these warnings be reduced? No, if you provide those warnings, maybe we can discuss. There are some warnings which you usually get for some weak springs added for the stiffness. I think those warnings are okay. You could live with those, but it all depends on warning to warning. So, I mean, there's no one line answer for this. Mr. Ketan Mahajan from Jalgaon, he is asking in which case we can use non-sway overrides for column design in ETABS. So if your column is such that it is not having, you have found out the Q value stability index, and it comes to be a case of non-sway, and you also don't have sufficient earthquake loads or lateral loads in your structural design, maybe then you can directly go ahead and select columns as non-sway. Otherwise, you can select your columns as sway columns. Let ETABS find out the K values depending on the stability index, and then let ETABS decide what is the appropriate effective length factor to be taken. Okay. All right. So these were the questions that were put in the Google form. Now I'll just go up in the comments and whatever questions were asked here, let us quickly take them. Okay. So very quickly we'll take those questions one by one. So Mr. Rajas Rasam is asking, this could be off topic, but what is he saying? This could be off topic, but which is a chart? What is a chartered engineer? Does it how to get it? Okay, chartered engineer maybe some other time, not today. Although we have discussed it before in great detail, I'll send you a link where you can see those discussions. In our project discussion series, we had done it. So I'm skipping this question. Mr. Santosh Kumar Chandoli is asking, there is opening in precast wall, but I am applying precast load on frame. So how should I model this opening? I'm not sure about this question. I'll skip. Uh, Mr. Shubham Kole is asking for the web contribution high shear. Yeah, so as I was telling you that in the IS code, there is no condition given when your steel beams. This question is from IS 800 2007 for steel beams. Steel beams which are laterally unsupported and they have a case of high shear, what to do? No direct procedure is given because in ETABS, the procedure given in case of high shear is only for laterally supported, not in ETABS, sorry. In IS 800 2007 code, the process given for design when your beam is subjected to high shear is only given for laterally supported beams and not for laterally unsupported beams. So what to do in case of laterally unsupported beams which are susceptible to or which are coming under the high shear case? So my answer is, in absence of any information that we have in the code, you follow the same procedure as is given. Follow the same procedure as is given for the supported beams, laterally supported beams. That is, you reduce that. You have to find out that I'm forgetting the terms, but there is a clause in section 9 given where they tell you how to calculate the reduced moment capacity for high shear cases. So I think in absence of any other information, you do the same. Okay, nice. Mr. Ketan Mahajan is asking how to design steel composite deck slab, where I can find references. You will have to go to some foreign authors because in Indian standards, it's not very clearly given for deck slab designs. So you can go to Eurocodes. I have some books. You send me a message on WhatsApp. I will reply. I will send you that book over there. It's by engineer Johnson, engineer PR Johnson, I think. He has in his book given some procedures for design of steel uh, deck slabs with concrete topping. Mr. Sai Vignesh is asking what is the requirement and when to provide side face reinforcement. As per the code, if footing depth increases, goes beyond 1000 mm, then you provide the minimum skin reinforcement. Mr. Magaj is asking, can you highlight about axial shortening for long term? It's a very long discussion. Uh, I don't know. We will not be able to take it right now. In one of our courses where we had discussed it, we had spent almost 2 or 3 sessions doing it. So not a topic for short discussions. It's a long discussion. Perhaps you read ACI R92 report. No, am I taking the name correct? ACI report number 92. Just a minute. I'll just confirm that number. So that report is one of the reports which tells you procedures for long-term axial shortening effects of column. There are some other documents like the FIP documents. FIP, I'm forgetting the name. So there are some FIP documents also. Perhaps you could refer them. Otherwise, ETABS has the ACI 209 R92. Sorry, ACI 209 R92 is a document, American code report, which you can refer to for calculations of axial shortening. There is very good document that you can refer online by PK Malik. He has given a workable procedure for the calculation of axial deformations of column that you can refer to. It's available online. You can download it from there. And it is based on this ACI method. ETABS also has the CEB-FIP method, CEB-FIP, and I guess it is the late 90 or even later than that. So you can read these documents and you can read some mathematical models through which you can do these calculations. Mr. Anukul is saying, please read the first and second question again. What happened? Uh, Modeling issues. Oh, okay. Acha. He had presented some image which I missed. So I'll put it the image over here and I'll share my screen to show you that image because it's an interesting question he's asking. So let me share that image. We'll just finish it in next 10-12 minutes, although we have overshot the time. So he's saying in this image, is it a good approach to model or we have to provide column at end of shear walls and remove in between beams? I don't know what he's saying. I don't see any reason why you are modeling this beam. You remove this beam. If you require this beam for some sort of load application, then maybe you can provide a null beam. But I don't see a reason why you're providing these beams over here. No need to provide a column at the ends because when we will be doing the detailing, we are going to detail or we are going to provide boundary elements over there. So no need to provide a column at the end and no need to provide this beam. Just have the shear wall. Okay, nice. Then where are the other questions? Mr. Animesh Kumar Singh is asking how can we provide anchorage of individual circular ties? No, I don't know. I'm not, I mean, I have not understood the question properly. How can we provide anchorage of individual circular ties in column? I'm not sure. I have also not understood the question properly. Perhaps if you can show some sketch. Personal development. He is asking built up column supporting another built up column, how to connect them with channel sections. So he's saying that he has two, I don't know, he has an I section column and this is at the bottom and then at the top another built up column which is comprising of channels over this, how to connect it with channel. So as I was mentioning in one of the earlier replies, this will to a great extent depend on the type of connection that the designer wants to provide. There can be different options over here. Okay, one of them option can be you provide a channel over this I beams, then provide a column over here. That can be one of the options. Another option can be to have a plate on top of this. Okay, then have another plate at the bottom of this column, upper at the bottom of the upper column. Connect these two plates through bolting and have stiffeners added. So there can be different options. I cannot have a one line answer for this. It will depend on the designer and the type in which they are choosing to carry out this design. Okay. Mr. Chinmay Sarkar is asking, it's not clear why unscaled we design and detail the building against scale force. So at the time of seismic, the structure responds more force than unscaled force. No, you must understand the logic why we do the scaling and why we do not do the scaling. You need to understand that logic first. Basically, we are doing the scaling for increasing the member forces because we actually want to design it as at a level which is similar to the equivalent static levels force that we derive from equivalent static. That is the reason why we do the scaling. Okay, but the actual deflection uh, will depend on the will depend on the vibrational characteristic of your building, and that will obviously be unscaled. So whatever deflection we got from, let's say, your response spectrum, we call it delta, and then we multiply it by the r. So this gives us the final elastic deflection. Now this delta will be corresponding to the unscaled, because that is how the actual situation is going to be. Okay, so that is the reason why we are going to take the unscaled uh, deflection value. Mr. Alek Kadwal is asking, can you look at my model? Okay, I'll look at it and maybe I'll answer you, or we can take it up in the next session. Mr. Ketan Mahajan is asking, can we take non-sway column design for only gravity load analysis? Yes, you could. Let's say if you're in seismic zone 2, it's not a very big structure, you could do that. Yes. Mr. Vijay Makwana is asking, in low-rise bungalow, if black cotton soil is up to 15 to 20 feet, but our foundation size is generally 5 feet by 5 feet, then what process we can do in soil strengths? No, if you have a bungalow and if your soil, black cotton soil, is 15 to 20 feet, it is best to remove all the black cotton soil. Otherwise, you will have a problem in the long term. You should at least remove the first 8 to 10 feet of black cotton soil, because that is the place where you will get a lot of moisture movement. So you should be removing that at least. If you don't want to do that also in black cotton soil, providing underream piles is a very good solution. You can do that. Okay. So if you have black cotton soil, best way is to go for underream piles. His next question is, what should maximum column steel reduce? Eh? What is this? What should maximum column steel? I'm not sure about the question. Not clear. Mr. Manoj is saying beam span 60 feet, तो बीम किस मेथड से डिजाइन करेंगे, बीम का डेप्थ कम चाहिए तो. So 60 feet single beam span is almost what, 18 meters beam. So I don't know what, I mean, you will have to go for some PT like thing if you want to control the depth also. Maybe you will have to go for PT beams. Single beam 18 meters, you are looking at least 1.5 to 1.6 meter depth if you don't want to go for PT. After that also, making RCC beams of such spans will have a problem of self-weight and deflection due to self-weight, so it will be a big issue. So in such cases, maybe you could go for steel structure instead of going for RCC beams. Okay. Mr. Vijay Makwane is saying column steel reaction criteria for different story height. No, there is no column steel reaction criteria. No. There is no criteria for deciding the column reinforcement on basis of story height. No, not a proper question. So I think these were all the questions. Mr. Tosh is asking, जब दो बिल्डिंग के बीच में सिस्मिक गैप 600 से 700 mm आ रहा हो तो क्या करना है? Why are you getting a 600 to 700 mm gap? I don't think you are getting. I mean, see, when you are going to find out the gap. So suppose you had two buildings in elevation. This is my one building. This is the second building. When you want to calculate the gap over here, usually what we do is, if this building was deflecting by delta 1, this by delta 2, usually we will take R1 delta 1, where R1 is the response reduction factor for this, plus R2 delta 2. This is the gap you want at top. Now what is the gap you want at the base? So in that case, you take the base deflection. So it will be some delta 0. So here, if you wanted to maintain a gap, it will be technically R1 delta 0 plus R2 whatever delta 0 2, delta 0 1. So this value at the base will have a very small deflection values, isn't it? So if you are looking at seismic gaps at the base, obviously you will take the deflection also which is at the base or near the podium level or whatever. So it will be of a smaller value. not a very high magnitude. At the top, if you're getting 600, 700 mm, you must be having those sorts of gaps available, isn't it? If you don't even have them, then I don't know what you can do. Mr. Magaj is saying, please look at my retaining wall question. Where was it? Okay. He is saying how to design retaining wall if there is vertical cutout at certain spacing. Then there that will be sort of a spandrel that gets created. So then you have to understand. So for example, in elevation, if this is my retaining wall, and he's saying if there's a vertical cutout over here, here, what to do, then this becomes a case of some spandrel like thing. So it's best that to properly understand this behavior, you actually model this wall, maybe in ETABS like software, and you remove these portions of the wall, and then you see what's happening. So this becomes a spandrel for you. So accordingly, you need to detail and design it. Okay. So my suggestion would be in such cases, also in 167002023 you will get some criteria when these openings can be neglected and when we have to take these openings, so you could have a look at them also. Okay. uh, but if these openings are large enough, you should consider them and design this as a spandrel. Mr. Vineet is saying, yeah, even if it's a retaining wall, same principles will apply. Even if it's a retaining wall, principles applied will be same. If slab, Mr. Vineet Kumar is asking if the slab, what is this? L. Okay, I think he's saying if the, okay, he's saying that if slab shows 20 mm, I mean, if the slab deflection is more than 20 mm, what should be done? Although the L by D ratio is matching, or the L by D ratio meets the criteria. Yeah, this is a good point he's making. So he's saying the L by D ratio is as per the codal provision, whatever the provision is, L by D of 26 in some cases, 20 in some cases, but the deflection exceeds 20 mm. Very good question. What should be done? So that L by D, I think it's more of a governing criteria. But if you are seeing deflections, actual deflections, you're getting more than 20 mm, I think your code does not allow it, because if my deflection is more than 20 mm, it will have the issues of serviceability for my non-structural elements like floorings, like flooring, brickwork, etc. So although your L by D may be as per the codal limit, but remember that that L by D criteria is only a uh, is it's only a suggestion, or it's only an indicative criteria given by the code. It's not a final criteria. So if you are able to calculate the deflection, and if you are seeing the deflection exceeding 20 mm, in my opinion, it should not be allowed, because it will lead to serviceability issues like cracking and other distress in the non-structural elements. Very good. Mr. Magaj is saying it's a retaining wall. If it's a retaining wall and if it's only having the vertical load and the out of plane movements and not so much of in plane movements, then you can think this as a normal opening. Then I think no need to take it as spandrel, and just ensure that proper load transfer happens around this opening. So maybe you can provide an element over here like a beam, which will help you to transfer the loads over here. Provide an element like a beam which will help you to transfer the loads over here. Ensure that sufficient reinforcement for out of plane movements is provided. Maybe you could do things like that. Okay. All right. Very good. So I think questions are over for today. So we stop here, and that's all we have. And now we will meet you in the session next week. So you can ask your questions, and then we can take it up next week also. Okay. That's all for today. We will see you next week with the session number 2. All right, then. Bye bye.